Hi everyone, we are Team 18 and our senior project was the Rogowski coil integrator. Our sponsor was RoMan Manufacturing. Our team is composed of Josh Dixon, Dixit Gurung, Connor Mathis, Patrick Rosso, and myself, Rachel Walters. An overview of our project is that we created an integrator that could take in different output voltages from a Rogowski coil and output a scaled down current that is proportional to the original current going through the Rogowski coil. The combination of a Rogowski coil and our integrator will replace the widely used current transformer. An example of what the output current of the integrator could be used for is power metering. The product that was designed was a PCB with 4 stages: gain, integrator, level shifter, and voltage to current converter. The integrator accepts input of 180 millivolts per 1000 amps at 60 Hz and 150 millivolts per 1000 amps at 50 Hz. It operates with a 24 VDC power supply with a tolerance of plus or minus 10%, has selectable inputs with scaling settings to integrate AC currents up to 1000, 2500, 5000, 10,000, and 20,000 amps AC, and has an output that has less than 1 milliamp bias error. The largest increase in temperature was 58 degrees Celsius in the voltage to current converter stage of the circuit. If this temperature increase is applied to the hottest possible environment, 60 degrees Celsius, the maximum temperature of the components in this stage of the circuit would be 118 degrees Celsius. All of the components in this stage are rated for 150 degrees Celsius. The remaining stages are further away from the heat source and should not be affected by the increase in temperature. Finally, the aluminum enclosure has dimensions of 4 inches by 4 inches by 2.125 inches. The output of the integrator is 0 to 5 amps AC at 25 volt amps for a 1 ohm external burden with 0.5% or less ratio variation and less than 0.5 degree phase shift, and can be seen here.